In this video, we are in the new chapter. It's going to be about partial derivative of the function, and it's going to be chapter 14 in the book. The first thing that I like to teach you is going to be about the function of several variables. Most of the time, the function that we are studying turn out to be the function in two variables, x and y. If you are comparing with calculus 1, so for calculus 1, you have the function y is equal to fx, and this one is going to be the function in variable x only. So it's going to be just, the value of x, and it's going to be the function, the value of the function turn out to be your y. And when you graph this function, it's going to be the two-dimensional graph. So you have the x-axis and the y-axis like this, and you're gonna have the graph y equal to fx as we study them for one semester, last semester. So you have y equal to fx like this one, okay? For calculus 2 that we are studying right now, we're going to begin the function of several variables. So you see that the variable that we are having here turned out to be more than one variable. It's going to be z equal to fxy. So it's going to be the function in two variables. So when we like to study the behavior of something in more than one variable, so we may construct the function or a formula that you can see here that is going to be the function in two variable fxy equal to x squared plus 3y squared e to the negative x squared minus y squared. Okay, and as you can see that when x and y are equal to 0, you get one value. When x and y are equal to 1, you get another value or something. So you see that when we have the function in two variable like this one, you're gonna have the domain or the value of the point turn out to be x and y, and the value of the function turn out to be on the z-axis. So you have z equal to fxy, and that is going to be you plug in x, plug in y, and it's going to give you some kind of this graph. This graph is called surface. So this one is called surface. Okay. And it's going to be the graph of the function in three-dimensional. So it's going to look like the surface of like a fxy equal to this formula, and you see that you're gonna see many surface down here. Okay, so for sine x plus sine y, you're gonna have another surface. So if you have the function fxy divided by 4xy plus 6 sine x minus 2y, we would like to compute f at 0, 1 and f at pi 2. Okay, so you see that when you see something like this, you're gonna just plugging in the value of x and y. So you have x, y, okay? So you're gonna put x equal to 0, y equal to 1 into the formula, and you're gonna reach the calculation for f01. So for f01, it's gonna be just 4 times 0, 1, like this, plus 6 sine 0 minus 2 times 1. And you see that this guy equal to 0. So this guy equal to 0, sine 0 equal to also 0, and 2 times 1. So here it's going to be equal to negative 2. Okay, so f01 equal to negative 2. And you're going to have f pi 2. F pi 2 is going to be 4, and x equal to pi, y equal to 2, 6 sine pi, okay? And you have minus 2 times 2. So you would know that psi pi equal to 0. So the final answer for this one is going to be 8 pi, okay, minus 4. So this one will be f01 and f pi 2 that you're looking for. Similarly, if you have the function up there, okay, so if you have the function fxy equal to x squared plus 3y squared times e to the negative x squared minus y squared. So for this one, you allow to find f01. If you like to find f01 for this guy, so you would just plug in x equal to 0, y equal to 1 into this function. So you get e to the negative 0 square, 1 square, okay? And this guy turned out to be 3, and you have e to the negative 1 for the value of this function. Okay, so this one will be how we obtain the value of the function. Okay, let me continue for the function g. The function g, you have gxy equal to e to the x minus 1 over x minus y. Okay, the question asks you to find g10, g1e, and ge1. Okay, so for this one, you basically plug in x equal to 1, y equal to 0 for the first value, and you plug in x equal to 1, y equal to e for the second value, and the third one you have to plug in x equal to e, y equal to 1, and you obtain all of them. Okay, so I allow you to do this one on your own first, and I give you the solution during the recitation. However, I'd like you to notice for the function g. For the function g, you see that you have x minus y on the bottom. And when you have x minus y on the bottom, if I ask you to compute for me g11, if I ask you, can you compute me g11? When you plug in x equal to 1, y equal to 1 into this function, the thing that you would get will be e to the first minus 1 over 1 minus 1. And you see that the yellow guy will give you the thing equal to 0. So you see that this guy is equal to 0. And it's going to make the value at g11 undefined. So you have this guy is undefined. Okay, so you not be able to compute for g11 in this function. Okay, so for this function g, you not be able to compute for g11. So g11 turned out to be undefined. However, if I ask you what are the value of x and y that this function turned out to be undefined, so you see that gxy is computable. So this one is computable if and only if the yellow guy, which is x minus y, turn out to be not equal to 0. Okay, so you have gxy is computable if and only if x minus y turn out to be not equal to 0. And we're gonna call this condition turn out to be the condition for domain, domain of g. Okay, so it's going to be the condition for the domain of the function g. So what does it mean for the domain? The domain turned out to be the set of all point x, y such that we be able to compute for the value of that function. So we go back to example 1. In example 1, you see that you have no restriction on x and y. You allow to put any x, y into the formula, and you'll be able to compute the product. You'll be able to compute psi x, you'll be able to compute double of y, and you'll be able to sum them. So in this case, for this function fxy, you see that any point xy turn out to be computable for the value of the function f. So in this case, the domain turn out to be any point xy. Okay, so it's no restriction at all. So it's going to be domain turn out to be any point xy. However, so this one I'm gonna say no restriction. Okay, so you have no restriction for this function. However, for this one, you see that this one or this condition will give you the restriction. Okay, so you have some restriction. So for this function g, you have some restriction, and for the function if you have no restriction for the domain. So we're gonna say that the domain of the function f, okay, so the domain of the function f turn out to be the set of point xy such that you have set equal to fxy is a real number, or it's gonna turn out to be f is computable. Okay, so you have f is computable. And so we like to find and sketch the domain of each of the following function. So when we write down the formula for the function, we're gonna assume that we're gonna have the largest possible domain. Okay, so like I say here that when you write down the function fxy, we're going to assume that we are working on the largest possible domain that allow us to compute for value of the function. Like in example 1 and in example 2, the domain of the function for example 1 is the thing that I already computed. It's going to be any point xy. Okay, so we know that f is computable for any point xy. Okay, so f is computable for any point xy. So in this case, we're gonna say that the domain of the function f turn out to be any point xy. So the domain of f is any point xy. And when we like to sketch the domain, it's turned out to be we just sketch any point. What does it mean to sketch any point? It's gonna mean that you're gonna just have your x and y like this, and you're gonna sketch for any point xy in this xy plane. Okay, so it's going to be our domain. Okay, turn out to be any point. Like in this example, you see that the domain you not have any problem with x and y in this formula. So you see this formula, this you can plug in any x and y, and you see that the domain turn out to be any point on the xy plane on the floor. Okay, so you have to imagine that you have the xy plane on the floor, and this guy turn out to be any point in your domain. Okay, so this one is in two-dimensional. This picture is in three-dimensional. Okay, so when you see the picture, it's turned out to be, this one is turned out to be three-dimensional. However, if you just take a look only on the floor, it's going to be just this xy. Okay. And for the second one, the function g that I highlighted yellow here, the condition that you have before is going to be this denominator cannot be equal to 0. So you have f is computable if and only if the bottom guy turn out to be not equal to 0. Okay, so the bottom guy turned out to be not equal to 0. And we have the domain turn out to be the point. Okay, so the condition that you get is going to be x minus y not equal to 0. And this one can be translated to x not equal to y. Okay, so when you have x not equal to y, we gonna just sketch this one in this way. So you see that you have x and y, and you have the line y equal to x. When you have the line y equal to x, it's going to be this line. Okay, so this one I use dotted. Let's just draw x equal to y first. So you have this one is the line x equal to y. Okay, so you have the line x equal to y, and you see that it's gonna turn out to be x not equal to y. The way that we're gonna indicate that we're not gonna include this line into our domain, the way that we're gonna do is gonna be we're gonna make this one into dotted line. So we make this one into dotted line by erasing. Okay, so we're gonna erase like this. So we're gonna erase. So you get this one, this one, this one. Okay, let me erase everything and I make this one into dotted line. So I get this one like this. So you have x equal to y. Okay, it's the same line that I make into dotted line, and I gonna shade. Okay, so we make this one into dotted line. Dot. So the line that use dotted line, we mean that we excluded this line from the domain, and we gonna shade something like this in order to show or in order to indicate that we are including this region. Okay, so we just shade this one and we gonna just have y and x like this. Okay, so this one is dotted line and you have x not equal to y. X not equal to y means that we gonna just exclude this line out and you're gonna have other region or other part of the plane that you are including in. Okay, so this one is going to be the way that we're going to sketch x minus y not equal to 0. Okay, so this is the region that you have. Okay, so this one you use the dotted line. Okay, so the dotted line means you're gonna exclude this one out. Okay, so this one is exclusion. Okay. The next one, you have fxy equal to square root of 1 minus x squared minus y squared. So for this one, you have the thing that sit inside square root will give you the condition for the domain. So you see that when you like to compute square root of something, so you have fxy is a real number. Okay, so you have fxy is a real number if and only if you have the thing that sit inside square root, okay, need to be, okay, so this guy must be greater than or equal to 0. So it must be positive or equal to 0, so it cannot be negative. So for this one, you have the green guy will be greater than or equal to 0. Okay, so it's going to be greater than or equal to 0. So this one will be the condition for the domain. Okay, and we gonna sketch. Okay, so we gonna sketch this. So it's gonna be one, what is called 1 greater than or equal to x squared plus y squared. Okay, and this one we like to sketch this region. Okay, so we like to sketch this guy. So the way that we're gonna sketch x squared plus y squared equal to 1 first. Okay, so we're gonna begin by sketching x squared plus y squared equal to 1. Okay, so if you recall x squared plus y squared equal to 1, you're gonna get a circle. Okay, so you're gonna get a circle and you're gonna have 1, negative 1, negative 1, and 1. Okay, so you have this circle, and this one will be your x squared plus y squared equal to 1. And the circle x squared plus y squared equal to 1 will separate the region into two parts. The first one is going to be the inside. So you have the inside, and the second part turned out to be the outside. Okay, so you see that it's gonna be inside or outside like this. Okay, so we need to know it's gonna be inside or outside the circle that we gonna have in this case. So for this one, how would we know it's gonna be inside or outside? So first of all, I'm gonna just say that I sketch x squared plus y squared equal to 1. Second of all, I'm gonna pick one point. Okay, so we're gonna pick one point not on the graph. Okay, so I'm gonna pick one point not on the graph, or I'm gonna say on the curve. It would be better. Okay, so it's gonna be not on the curve. Okay, so I'm gonna pick one point not on the curve, and you gonna just maybe pick which point. So the easiest one is gonna be pick 0, 0. Okay, so we can pick just the easiest one. You just pick 0, 0. So after you pick 0, 0, you're gonna plug into the inequality. Okay, so you plug into the inequality. So you get 0 square plus 0 square smaller than 1. Okay, so you plug into the inequality. So you get 0 square plus 0 square. Let me put in the easier way to see. So you have 1 higher than 0 square plus 0 square. And this one turned out to be true. Okay, so this one turned out to be true. So you're gonna say that, hey, it's turned out to be true and my 0, 0 is at this point. Okay, so this one is your origin 0, 0. And the way that we gonna answer turn out to be, we gonna answer in the way that we have, we gonna answer in the way that we gonna shade to that region. Okay, so we're gonna shade to what point? So we're gonna shade to 0, 0. How would I know that after we have is true? So it's gonna be inside. Okay, so we're gonna say that we're gonna shade to 0, 0. So what does it mean for shading to 0, 0? It means that you gonna have this answer only. Okay, so you're gonna have this answer only. So it's gonna be you're gonna shade only inside the circle. So this one is the pink highlight that I shade. Okay, so you shade to 0, 0. So it means that you are shading only inside this circle and the outside not gonna be shade. So this one will represent one. Okay, so this one will represent one higher than x squared plus y squared. Okay, so this one will represent one higher than x squared plus y squared, and that is gonna be the inside circle that we have right now. Okay, so that question number 3. Okay, so you have the condition for the domain, and you're gonna have is greater than or equal to 0, and you are sketching the region x and y like this. So you have x, you have y. Okay. For the last one, you have fxy equal to log x squared minus y. So you have log x squared minus y. So you see that you have the function log. So for the function ln, okay, so ln, this guy is a real number. If and only if you have the thing that sits behind the log is positive, okay, so you have ln is a real number if and only if the thing that's sitting behind the log is positive. So we have fxy is a real number if and only if you have x squared minus y is positive. Okay, so you have x squared minus y positive. So in this case, this one will give you the condition in order for the domain. Okay, so this one will give you the condition in order to find the domain. So it's going to be x and y, that you have x squared minus y higher than 0. And this one can be translated to x squared higher than y. Okay, so this one is x squared higher than y. And you gonna sketch, okay, so the first one, you gonna sketch y equal to x squared. Okay, so you're gonna sketch y equal to x squared, and the second one, you pick one point not on the curve. Okay, so y equal to x squared has the graph. Okay, so y equal to x squared has the graph parabola open up. Okay, so it's gonna be like this. So you have y equal to x squared. And the thing that you need is x squared more than y. Okay, so the thing that you need is x squared more than y. So for more than, you see that this one not include equal. Okay, so it's not include equal. So what does it mean to not include equal? It means that you gonna just have this guy in a dotted line. Okay, so let me just erase this one. And the parabola that we're gonna use turn out to be dotted parabola. Okay, so this one is y equal to x squared. This one is y equal to x squared in a dotted way. And you see it's gonna be inside parabola or it's gonna be outside parabola. So you're gonna see two regions, okay? So you're gonna determine the yellow one or the blue one by just pick one point, not on the curve. So in this case, we're gonna pick just one point. Let's use the one that quite easy, 0, 1. Pick 0, 1. So after you pick 0, 1, you're gonna plug into the inequality. Okay, so you're gonna plug into the inequality. So you get 0 square more than 1. Okay, so you plug into the inequality. And in this case, it's turned out to be false. Okay, so it's turned out to be false. So it means you're gonna shade away. So it's gonna be you're gonna shade away from 0, 1. Okay, so you're gonna shade away from 0, 1. The way that we're gonna shade away from 0, 1 is gonna be we're gonna shade to the blue highlight. Okay, so you're gonna shade to the blue highlight. So the way that we're gonna shade turn out to be we're gonna have only for the blue highlight only. Okay, so this one is going to be the part that we have for this one, and it's going to be the domain that we have. Okay, so when you shade here, it's going to be just you shade down. Okay, so you're going to shade down and you use dotted line. Okay, so it's going to be dotted because we not including this curve. Okay, so it's going to be just our guideline in order to know the region that we gonna shade to or we not gonna shade to. Okay, so that's how we answer this question. Okay, so that is gonna be about the domain. The next one that I'm gonna teach you is gonna be about the limit. The limit notation turned out to be the same as in calculus 1. However, it turned out to be the function in two variables instead of one. So in this case, you see that the picture is look the same as in calculus 1. However, the thing that we are doing is turned out to be two variables. So you have x and y. So you're gonna just find the limit. First of all, the easiest way to find the limit turned out to be you can just try to plug into the formula to see whether you be able to compute for value. Like in the first example, so when you plug in x equal to 1, y equal to 1 into 3 to the x squared plus y squared cos pi over 2x plus y, this guy will allow you to have 3 1 square cos pi over 2 times 1 plus 1. Okay, so it's gonna be 3 square cos pi over 3. So it's gonna be 9, and cos pi over 3 is 1/2. Okay, so this one will be 9 over 2, okay, for your final answer. Okay, so this one will be just the easy way to compute for value of the limit. Okay, so it's like doing Cal 1. However, it's going to be just plug in x and y accordingly. The second one, you like to find this limit. So it's going to be log 1 plus 2 plus 2 times negative 1 over 3 negative 1 square minus 2. And this guy will be equal to log 1 plus 2 minus 2. And you have 3 minus 2. So this guy equal to log 1 and log 1 equal to 0. Okay, so the limit is equal to 0 in the second one. And in the third one, you like to find limit xy go to 1 negative 1 1 arctan xy over 2x squared plus y squared. So this guy will be arctan. You have negative 1 times 1, 2 times negative 1 square plus 1 square. And this guy will be arctan, okay? And you're gonna just have negative 1 over 2 plus 1. So it's gonna be just arctan negative 1/3, okay? And for this one, we not be able to compute because we don't know the value of arctan negative 1/3. So you just leave your answer in this form. Okay, so that is going to be how we find the limit for each question that we have here. And the first technique is called just plugging in. The second way to find the limit turned out to be also using calculus. One is going to be you like to find the limit by factoring. Factoring is mean that you try to simplify the term that gonna cost you undefined term. For example, you like to find limit xy go to 1 of x squared minus 4y squared over x squared minus 2xy. When you plug in, okay, so when you try to plug in, you're gonna get 2 square minus 4 1 square over 2 square minus 2 times 2 times 1, okay? So this guy will give you 0 over 0, and this one will be the thing that we call indeterminate form, or IF last semester. Okay, so this one is the indeterminate form. So we're gonna have to kind of do the simplification, and we'll be able to get rid of the problem that cause the top to be equal to 0 and the bottom to be equal to 0. So in this case, you're gonna try to factor. So you see that this guy, you have x squared and you have 4y squared. It's gonna be 2y squared, okay? And on the bottom, you see that you allow to pull out x and you get x minus 2y on the bottom. And this guy, you're gonna have the factor x minus 2y, x plus 2y, and you have x x minus 2y, and you get rid of x minus 2y on top, x minus 2y on the bottom. So you get x plus 2y over x. Okay, so this one will be just the simplification that we have, and you see that we get rid of the problem x minus 2y on top and on bottom already. So we gonna have limit x, y go to 1. Okay, so you have limit x, y go to 1. And you would just plug in x equal to 2, y equal to 1. So it's going to be 2 plus 2 times 1 over x equal to 2. So this guy will be 4 over 2 equal to 2. Okay, so you have the limit equal to 2 in this case. The second one, okay, so the second one, you have limit xy go to 1 negative 1 of x plus y over x minus root xy plus 2y squared. So you see that, hey, it looks like calculus 1, okay? When you put x equal to 1, y equal to negative 1 into this function, it's going to be 1 minus not 1 minus. So when you plug in, it's going to be 1 plus negative 1 on top, and you have 1 minus square root 1 times negative 1 plus 2 times negative 1 square, negative 1 square, like this, okay? And this guy turned out to be 0 over 0 again, okay? So this guy turned out to be the same thing, that indeterminate form, and it's going to be 0 over 0, okay? So we need to perform some simplification in order to get rid of the problem. The problem should be x plus y, okay? The problem should be x plus y. So for this one, we're gonna try to get rid of the square root like we did for calculus 1. We're gonna multiply the top and the bottom. Okay, so you multiply the top by x plus square root xy plus 2y square. The bottom is x plus square root xy plus 2y square. Okay, so that our top and bottom. And you would just have x plus y, and the thing that you have on top is x plus square root xy plus 2y squared, okay? And on the bottom, you're gonna just multiply, so you get x squared minus xy plus 2y squared. Okay, and you see that you can just factor this one, so you have xy, and the blue guy, you just copy it down, so it's going to be xy plus 2y squared. Okay, and you're gonna try to factor the red guy. So this one can be factored into two parentheses because it turned out to be just a quadratic. So you have x plus y. Okay, so it's going to be x plus y, and it's going to be x minus 2y. Okay, so you see that you can check the middle term. It's going to be xy minus 2xy. So it's going to be negative xy. Okay, so for this one, okay, so you see that the final term is going to be y times negative 2y. So it's going to be negative 2y. Okay, so don't forget that negative multiply to this term also. So this one, you're gonna just get rid of x plus y and x plus y. So this will allow you to take the limit. So this one will be equal to limit x, y go to 1, negative 1 of x plus square root xy plus 2y square over x minus 2y. Okay, so it's going to be over x minus 2y. And you gonna just have 1 plus square root 1 negative 1 plus 2 negative 1 square over, and you have x is 1 minus 2 minus 1. Okay, so in this case you would have 1 plus 1. Okay, so it is equal to 1 plus 1 over 3. So it's gonna be equal to 2/3. Okay, so it's gonna turn out to be equal to 2/3 in this case. Okay, so this one is how we have the calculation in order to find this value of the limit. You see that it looks like calculus one. However, when you deal with the function, it turns out to be the function in two variables, x and y, instead of only one variable that like we had last semester. Okay, I let you do number 3 on your own first. I'm gonna give you the solution for at the recitation. Okay, and for the last one for this clip is gonna be number 4. For number 4, as you can see that it's gonna turn out to be like many term here, and it's turned out to be kind of messy here, and it's not gonna be quadratic because you have 4 terms. For quadratic, you most of the time has 2 terms or 3 terms. So for this one, the thing that we're gonna try to factor is gonna be we're gonna try to group them, or we're gonna try to pair them. So for this one, when you plug in x equal to 1, y equal to 2, I'd like you to try on your own. Okay, so when you plug in x equal to 1, y equal to 2, the thing that you would get will be 0 over 0. Okay, so the thing that you would get will be 0 over 0. And we're gonna try to group this one in this way. So we're gonna just have the first group, which is the first 2 pair, and you're gonna have the second group, which is I put parentheses for the second one. However, when you see something like this, the thing that you're gonna have here is turned out to be, hey, when you put parentheses like this, the value not the same. Yeah, I know. So I'm gonna have to erase this guy first. Okay, and I like to keep the expression to be the same. So you're gonna just have 2x cubed plus 6xy. Okay, so this is one term. And I have minus of x squared y plus 3y squared. This is the second term. You see the thing that I did turn out to be this yellow parenthesis. Okay, and I have to change the minus sign to plus sign. Okay, so you see that when I put parentheses, this minus sign turn out to be this plus sign because you need to multiply the negative sign into the parentheses. So this would give you this term, and you have this guy on the bottom as well. So you have 2x to the 4th, 2xy squared, okay? And you have negative, you have x cubed y plus y to the 3rd. And this one is the same thing as I did on the numerator. So I just put parentheses, and I see that this one negative have to be positive. It have to be opposite. in that case. Okay, so after I did this simplification, the thing that I can see is going to be, hey, can we pull out 2x on the first parenthesis? You can, so it's going to be x squared plus 3y on top, okay? And can we pull y from the second parenthesis? So you have x squared plus 3 on the second one, and you gonna can pull out 2x from the parenthesis on the denominator. So you can just have 2x again, and this one you're gonna get x to the third plus y squared. And finally, for the second one, you get y, and you have x to the third plus y squared, like this. Okay, and you see that you have, I forgot something. I forgot y, right? I pull out only y, one y, so I should have y up there. And you see that this is a common term on the numerator, and you also have another common term on the denominator. Okay, so for this one, you allow to just have 2x minus y, and you have x squared plus 3y over 2x minus y, okay? And you have x to the third plus y squared on the bottom. Okay, so for the green one and for the blue one, and you see that you just get rid of these two guys. Okay, so for this one, it's going to be limit x, y go to 1, 2 of this term. Okay, so it's going to be of this term. Okay, so I'm gonna have to copy this guy down. So you see that it's gonna be limit x, y go to 1, 2 of x squared plus 3y over x to the third plus y squared. And you're gonna just plug in. Okay, so you're gonna just plug in for value. So for this one, it's gonna be 1 squared plus 3 times 2 over 1 to the third plus 2 squared. Okay, and for this one, it's going to be 1 plus 6 over 1 plus 4. So it's going to be 7 over 5. Okay, so this is how we do this question. Okay, so it's gonna turn out to be the common one that you have. Okay, so I gonna stop here, and we're gonna continue next time about when we have the limit that does not exist in two variables, how we be able to determine them.